All right, welcome everybody to another product spotlight. And as always, we are bringing you the best and the brightest here in Dave Cooper Live. So today we have Brave Control Solutions Incorporated delivering custom automated robotic solutions to world-class manufacturing clients, enabling the prefab and offsite construction industry to build it better. Today, we will welcome Brent McPhail as we shine a product spotlight on automation for construction, automation equipment, automation solution, system integration, cycle time analysis. They are winners of the 2020 Innovations Award for Construction Automation, designated by global technology company ABB. Brave Control Solutions is empowering prefab and offsite construction clients to build for the future, optimizing their operations with turnkey innovative solutions. They have been delivering automation solutions to Fortune 500 manufacturers across North America for over 10 years, which is amazing. And we look forward to showcasing them in just a moment. But first, we always need to thank our sponsors, because without our sponsors, we cannot bring you all this great information that you use on a regular basis. So thank you to Forward Solutions Group for allowing us to deliver these examples of construction innovation. Forward Consulting Group is successfully driving companies to succeed where others have failed. To learn more about Forward's recent acquisition of Moducore, an ERP solution for offsite manufacturing, contact Ben Hershey at forwardsolutionsgroup.com. Thank you to Forward Solutions Group. We really appreciate all of your support. And also, thank you to Howick Ltd. And by the way, the CEO of Howick will be on the Dave Cooper Live show next Wednesday. So mark your calendars, 1 o'clock. Howick has a long history of innovation in cold form steel manufacturing and produces innovative precision roll forming technology for customers throughout the U.S. and the world. You also want to check out their machine buyer's guide for the offsite modular construction or fast build construction with light steel for framing at their website. So please go to howickltd.com and download that free buyer's guide so you can make informed decisions on everything that you are doing. All right, so we're having a lot of fun here today. I'm looking forward to having everybody join in. If you do have a question today, please put a Q in front of your question. That's always a big help. We love it when you put a Q there. It makes our lives easier to find everything that we are looking for. So without further ado, and maybe with a little bit of a cheer, let's bring in Brent McPhail. Hey, what is happening, Brent? Thank you for coming on the Dave Cooper Live show today. We really appreciate you being here.
Hey, Dave, how you doing? Good to see you.
I'm doing great. I'm doing great. So, listen, I think this is amazing having you guys on. We're always talking about automation and construction on this channel and taking it to the new levels that we need to take it. You've been in this industry for quite some time. You've been working with Fortune 500 companies. You've been in the automation industry for a long time. You understand the value, the data that is driven, and you're even willing to use some controversial terms like snowflakes when we talk about this stuff. So I'm looking forward to having a great conversation with you on that. But before we get started, Brent, I need you to do one thing for me. I need you to tell us everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will call your mother. And if we have her on the show, you know it'll be embarrassing, even though our families are very similar and that's kind of what we do anyhow. But let's just get it all out on the table right now. You got 2 minutes to do it.
Sure. Thanks, Dave. And obviously, my first live podcast. Honored to be on the show, and hopefully we can get some good information out there. So, yeah, I'm Canadian, born on a farm, raised on a farm, a lot of hands-on ability and responsibility with that. Started my company in 2008, but worked in the automation industry since just before 2000. Predominantly working with, let's say, Fortune 500 companies, Ford, GM, Chrysler, and solving sort of our history's been tough challenges and tight timelines. Always looking for a way to be more innovative. You know, we don't tend to build standard solutions. And so back in 2000 and about 18, 19, a construction company came to us, asked us to help them with a 3D volumetric chassis. And I can talk about that a little bit later when we get into Snowflake manufacturing. But it really, in that last 3 years, has shifted my focus. And now we're chasing after this these important things, the global housing crisis and the skilled trade shortage. So basically just trying to be a part of, making a meaningful contribution to our society versus, the automotive way, which is just saving fractions of pennies on shareholder value by coming up with these innovative solutions. So my team and I are super excited about the challenges that we're seeing in the previous 3 years as we're gaining this domain knowledge in construction automation.
Yeah, and you know what? The challenges are big and they're there, but there's so much opportunity for improvement, and that has to excite you.
It certainly does. I mean, when you have a company like this, and don't get me wrong, when I talk about the automotive industry, for over 10 years, we've solved really difficult challenges for them from all makes of process, casting facilities like First, the aluminum F-150, we helped convert the tooling over to run the aluminum and the steel in the same line back in 2014. So we've always found our joy and our excitement in innovating. And while there's lots of innovation still to be done in the automotive industry, what we're finding in construction is that we're going back in time. It's like the 1960s of the automotive industry. And one of the reasons I'll say that is, the technology's been around for that many years, for 60 years, but you see next to no adoption in construction. There are many reasons for that, and we're helping to solve some of those reasons.
Well, I love it. Well, listen, everybody, we are live on LinkedIn, YouTube, Facebook, Twitter. That's right, Twitter. So make sure you tweet us every once in a while, and Twitch. And if you're not subscribed to our YouTube channel, please support us by subscribing to our YouTube channel. It means all the world to us, and it helps us to continue grow our industry and bring the education and the knowledge to the people that are looking for it. And there's a lot of people out there looking for it. So, Brent, let's hop into this a little bit, right? You talk about Snowflake manufacturing and the paradigm shift. Now, we all know, we've heard the Snowflake word out there many, many times over. How do you relate that to our industry?
So one of the interesting things, I'll tell you the story of the first client that we had. And so as a company that solves manufacturing challenges using technology, it's not unusual for us to be presented with some unique opportunities to come up with ideas. And so we had a client come to us and they said, we won this hotel and there's 150 different modules, whatever the number was in this hotel. And we need a piece of automation that can build the 3D volumetric high strength steel exoskeleton for these things. And we said, okay, 150 different units, that's quite a few. But we have this ability to do this with some recipe decision-making in our automation, so we can do it. And as we dug into it, and we started to look at the different variations, we really realized quickly that there was only about 12 major variations in size, length, height, whatnot. And then the rest were minor variations. So we kind of convinced ourselves that it wasn't that big of a problem. And we started to set out to do the design and the engineering. Well, midway through that first project, our customer came to us and they said, great news, guys. We've won another building. And of course, we're like, that's great news. This is really going to take off. Like your fledgling little modular company is going to be something. That's awesome. And then they said the things that I'll never forget. And that was, so as soon as we're done, our architects are done designing the next building, we'll give it to you guys so that you can make sure it works in your machine. And that's where my engineers and I looked at each other and we're like, no, it doesn't work that way. You can't build the factory and then design a product after the factory has been built. And so what I coined Snowflake manufacturing, and it's one of the biggest challenges that we've seen, and why I say it's more than just the intellectual property that we've developed, it's actually a paradigm shift for this entire industry. And what I mean by this is, I call it my F-150 story. And so I'm looking across the river right now into Detroit, and the home of advanced manufacturing, automotive manufacturing in the world. And so the F-150 is a very complicated piece of equipment. There's thousands of different permutations when you go to their online configurator of how you would want to build that. But there's one thing that is always true about that F-150, and that is that it and every one of its options are 100% known before you build a factory to make 1 million of those a year. And so very quickly, when we got into the construction world, we realized that this is never the case. And, there are people out there that say, no, we standardize and we're going to standardize these things, but there's nothing that's sustainable over a multi-year period that won't require you to reinvest and redevelop your automation, right?
Yeah, and I see two things in this, Brent, and you're absolutely right. Some of the newer manufacturers are coming on and designing with that intent, right? So there's a couple of them out that have adopted this manufacturing process where what the end product is before you even start building the manufacturing facility. So all of that design information is built into it versus modifying it along the way. But we have this huge infrastructure of all these old factories too. And this is getting back to, well, how do you incorporate, this technology into those older factories, or is it not possible to do that? It would be one question, but it does make a lot of sense to put the money in upfront, like the automobile industry, to design knowing what the end result's going to be. But we're struggling with that in our industry, wouldn't you say?
Well, and that again is this paradigm shift. So when a client comes to me and says, Brent, I don't need your CAD to fab technology. I don't need you to go from the Revit drawing, reconfigure the fixture and go, because we've standardized down to 15 products. And what I challenge them with is the reason it's a paradigm shift is because their clients don't buy that way. So in the automotive industry, because of 100 years of building cars, people have accepted the fact that they can't customize their cars infinitely. But as soon as one of these clients that says they've built 15 standardized things or 20 or whatever it is, and someone comes to them and says, yeah, but I want you to build, I got a project for 10,000 houses, but I need you to build it my own custom way. Well, they go, okay, yeah, we'll do it. We'll take it because it's such a big thing. And so once you've invested in that factory, you've kind of locked yourself into this mold. And so even the guys that are currently thinking in a standardized mindset, standardization helps, but there's an intersecting line between our standardization and flexibility, and that's the sweet spot. And so, as the other point you mentioned was a factory that already exists. Well, we can bring in smart tools with this Snowflake manufacturing methodology to replace sort of the low-hanging fruit pieces in existing manufacturing operations, and when you're talking about an entire factory. So the challenge is that there's not really a lot of standardization or mold set yet, but that's also the opportunity to kind of just go in and we'll get into sort of we've got one of the topics we're going to talk about is this IC maturity assessment that helps get that sized right, I guess.
Okay. And so with that assessment, and I know we're going to get into this, but food for thought. I mean, it's going to be really great to understand, like, I'm a factory, I'm out here, I'm already existing, or I'm thinking to build one. For the end of the conversation, I want to know, like, what does your team at Brave Control Solutions do to help them understand what the value proposition is for them and what the return on investment could possibly be? Yeah. Are you seeing more and more factories take the approach that you're talking about and designing with the end in mind? Do you see that paradigm shift happening? Is it moving to that next level?
So we're seeing, the challenge is that we're literally seeing all sorts of everything, right from people that are building modular in factories, or people that are general contractors that are doing self-perform work, or electromechanical plumbing contractors that are trying to do kitting work. And so, and actually, you just said something that always reminds me, I don't do a great job of explaining myself. No one knows what a system integrator is outside of a very niche group of people from Detroit. And so basically at the highest level, what we do is we take existing technology and we integrate it together. So if you think of a computer has a hard drive, has a monitor, has a keyboard. Somewhere, somebody has taken all of those different components and made them all work together in harmony. And the one sort of, I guess, difference is in small cases where something doesn't exist, there isn't that Lego block existing. So my company will develop that technology from a first principle, but we try not to do that because the more things we can buy and integrate. So I don't necessarily always do a good job of, I guess I took over my 2 minutes there, but.
All right, listen, we're beyond the 2 minutes. We're into this now. So just, put on your hip waders and let's jump right in. I think, system integrators, and you're right. And this goes back to, I say this all the time, Brent, is we're really good at talking to each other. We're not very good at talking outside of our circle, so we can grow the industry and really bring in, the different people that should be in our industry. Because, hey, listen, if I went to Google's technology headquarters and sat in a conference room while they had a conversation about data and algorithms, I'd be lost. I mean, I wouldn't know a darn thing that's going on. And I think we have the same problem in our industry. So Joel Hutchins is joining us today. Joel had a question. Might as well put it up while we have it. How does design automation play into this?
So Joel, what do you mean by design automation?
Yeah, I think he's talking into the design of the automation into the upfront process of building these manufacturing facilities. If I'm correct, Joel, but correct me if I'm wrong.
So there's a couple ways. What I find in this industry is that you guys are preoccupied with BIM models and designing things. So we're going to get into DFMA, but designing for the manufacturing environment. But then there's designing for the automated manufacturing environment, which is another step removed. And so how if I think about sort of tackling the design for automated manufacturing, we don't have pre-existing machines in this industry. So the machine that we made for the 3D volumetric, if that 3D volumetric machine existed, then it's much easier for us to show design architects what they need to do to play within the parameters. But the goal that we have right now is we first got to conceive the machine, then we have to set the constraints in a constraint-based system, and then we have to, then when we have the constraints, then we can start to build tools and methodology around how architects can design. And so the way I kind of describe this is like in the automotive industry, if you were to peel the skin off the side of your F-150 off the door, you would see all kinds of locating holes, pins, pads, gripper points, and all of those have a part in the process of manufacturing. So let's say you're a junior designer in the automotive industry and you come in on your first day on the job, you're not going to intuitively know to put those things in there. So your senior designer is going to let you design something. It's not going to work in the automation. He's going to make fun of you, have some good fun, but then he's going to say, listen, or he or she is going to say, look, here's what you have to do for Operation 120 and Operation 500. These are the things you need to do. So there's this tribal knowledge that exists in the automotive industry. In construction, we don't have time for a generational change. We have to get this in the next 2 to 3 years. We're in the early adopter stage. So what we need to do is to be able to visualize the actual machinery that an architect may not be used to seeing. So I'm talking about the automated machine that's going to make the product. Then we have to let that architect design what he's going to design, run a trial in what we call our digital factory so that he can then see the collision points. And the higher point of this, I mean, is a robot might be a foot wide and it physically might not be a foot wide, but the operating space it needs to maneuver in might be a foot wide. Well, an architect is only concerned with optimizing the space, the aesthetics of the thing and the structural integrity. He's not thinking about this manufacturing side. And if he looks at the robot, he says, look, that robot's arm's only 2 inches wide. But our designers go, yeah, but in order for it to reach this point, it has to swing around. So the worst way to fix that is what I just described, which is a break-fix methodology. But that's what we have today because we're in the very early adoption. When we get the machines conceived, when we get the constraints defined, then we can go to the BIM models and we can put in design limitations that won't allow the guy to give him the freedom of motion of putting 2 uprights or 2 supports or 2 beams too close together for the automation to handle. And so today's solution is, if it can't be fully automated, we have the human beings that have to come in and do the manual intervention. So maybe we set off with a business case to achieve 100% automation, but because of limitations, we get you down to 60%. Well, those limitations are affecting your ROI that you calculated for your business case, and it's really frustrating. So the more that we can get this sorted out, get the designs that work with the automation, the easier it is for us to actually achieve our financial goals on the end products.
Right. And how do we get the education out there, right? Because like you said, this is tribal knowledge to the, other industries that are manufacturing automobile, what have you. How do we get this general knowledge, what is taken for granted in those industries, and help educate our industry to get a further adoption of this technology?
So honestly, what we're doing today and asking this question is a good first start. And so the first thing is we have to create an awareness. And so I don't know how many people we have tuned in right now, but hopefully it's like, hundreds of the right people. Number 2 is, here's the Ford scenario. The designers for Ford sit on the umbrella of Ford, but that's not what we've seen thus far. So an architectural firm, they could be leading the project, or they could be a sub to somebody else. So they're far removed from the people that are actually going to manufacture it. And so what we need to do is we need to get, even without the automation, we need to get the designers and the manufacturers sitting at the table together and communicating the same way. And in order for that to be meaningful, it gets back to constraints. So we have to talk that, we are not at a point where we have a Star Trek replicator where you basically say what kind of tea you like and it forms the coffee cup and it forms the tea in the cup and you drink it. So we have all kinds of limitations in what our automation can do. But when we get to that level where you're wanting to buy some type of a Snowflake manufacturing or RIP, which is the CAD to fab, take the Revit model, automatically give you the parametric data to then adjust the fixture. And we'll show some videos of this if we have time, adjust the fixture and then fasten it. Until we get to that point where we can make that proper digital twin, or what we call a digital factory, that's sort of like a tool and an aid. But I think there's an understanding at the early stages and a pre-predicting that you're going to run into this difficulty, that once you know that, you can then do something to sort of mitigate it, even if it's just meetings and stuff at the early stages.
Right. we talk about automated for manufacturing, DFMA, and I have this up here, and we talk about DFMA on our show quite often. But what about DFAMA? I'm not sure that a lot of people understand that terminology because we don't talk
I
about
just
it
made it
much.
up, so they probably wouldn't. Yeah.
Yeah,
DFAMA is designed for automated manufacturing. And so when you design for manufacturing and assembly, what I always talk about is that in traditional construction has been going on for thousands of years. The most sophisticated robot that you could ever find is a human. And so we will build a tool if we need to get into that area, to reach something, to change something, to do whatever it needs to be. But when you start to talk about automation, you now live in a world of constraints. Robots will only do as they're directed to do. And so if we don't have the insight or the understanding of the entire scope of the problem to be able to give that answer to that robot ahead of time, the robot's going to fail. And so that DFAMA is a process that I'm discussing, which is, we first have to design the machine in a virtual and a real world. And then once we have that physical image, that physical machine design, then what we're able to do is show it and say, okay, now we can set the constraints up. So when I say this, to put it in practical terms, how long, how high, how wide, what are the different material types that are going to go in there? What are the spacing between the material types? What are the different types of fastening techniques? So if it's welding, which is our specialty, but if it's also cutting, nailing, gluing, which are all other opportunities and applications that we've also built, you've got to be able to define the limitations of that. So for example, in a welding application, you've got to be within 0.2 of a millimeter of where your target is to be able to make an accurate weld. So these all have to be designed and understood. And that's sort of the bigger gap that's missing there.
Yeah, sure. And I can see that, but I think, one comes before the other, or do they come together when you talk about, DFMA, design for manufacturer assembly, and DFM, what was it again?
AMA, yeah, it's a made-up term. It may not get any traction. Who knows? It's for automation. It's designing for the equipment. So honestly, I don't think they can happen in parallel, because it's almost like, how would you conceive or design something without knowing? Like, how could you design for an automated manufacturing system if you don't know the limitations of that automated manufacturing system? And so what we've been doing is, I've got this formal process we use. It's our double diamond discovery. And so, but basically what we call it is, first you've got to, I'm drawing a blank. The second part is define. The first part is discover. So you're discovering what you need to solve. The second part is define. Then you develop the solution, and then you deliver the solution. And so that first two diamonds, it's an open funnel. We need to interview our client around the challenge that they face. And we're finding this a lot with the GCs and their self-performed work. I walk through a facility and I see nothing but opportunity where they have repetitive tasks. And so from my year's experience, I can be like, we automate this, we don't do this, we don't do this. But then what we have to do is so once that's there, then we define what we can do. Once we have that definition done, then we can put together a concept. Then we can say, okay, now get your designers in here, and we got to show them the rules that they need to play within to maximize your potential. And so it's not a one before the other, but it's almost like a dance. One step, then another step, then another step, then another step. Now, the beauty is, once you have a 3D volumetric machine concept done, now we're talking small, medium, or large. So that first initial phase is done. So now that concept is there. So it's much easier for us to show it. But someone's going to come to me and they're going to say, Brent, we want you to build a robot that can visually examine a room and install drywall and install mud. So that machine doesn't exist yet, but it could exist if the right client comes and says, hey, this is what we want to do. So then we'd have to do that dance back and forth to get all those constraints figured out. And then once those constraints are figured out, then we can go to the architects and say, here's the limitations where we can and when we can't, right? So it's certainly, again, we're in the early stages. This is not a known science.
Well, it's not a known science. I mean, we're in the early stages in our industry when it comes to this stuff, for sure. But I think the good part about this is there's a lot of industry knowledge on how this really truly works. If we, as an industry, can kind of get out of our own way and start thinking a little bit differently and start incorporating some of these things. But we also know there's big costs behind reorganizing and thinking differently, and we'll get into that in a minute. But you were talking about this just a second ago, a little bit, manufacturing organizational structure, right? So there's a knowledge base that comes with this as well. And there's different roles within, organizational structures. how does all this play into it? Because when I think of a factory, it's not 2 people, it's hundreds
No.
of employees typically.
You're right. And so this manufacturing organizational structure has come up with experience with clients that we're working with. And I'll admit, I wasn't aware of this. It's these logical but not intuitive things. So I would see a offsite construction factory, and I'd walk in and I would see joint health and safety and a cafeteria and, Kanban boards and things are labeled and there's fork trucks. And I'm like, this is a factory. This is clearly a factory. And it wasn't until we started to make requests like, hey guys, we have a problem with some of the material coming in here. Can we talk to your process engineer? And they'd say, process engineer, you mean welding inspector? And we go, okay, let's go with that. Well, it dawned on me that I had to take a few steps back, and I realized that a massive gap, and it doesn't matter whether you have an existing factory or setting up a new factory. When you look at, the automotive manufacturing at a Ford plant, nobody sets up a factory in Ford from first principles ever. They have a playbook that they've done for factory after factory after factory, and the ants that are required to do the things they need to do, they just fall into place and they do those things. Well, we're looking at a complete different industry now. And so things like, that I always say, if you're going to switch over to an automated manufacturing, one of the biggest misconceptions you'll have is a material planning and logistics problem. So what you've gone through now is everything kind of being built at a steady state to much more of a batch building process, where in manufacturing, advanced manufacturing, we need raw materials, we build things quicker, we need to store them. And then in order for the ROI to make sense, we switch over the tooling to do the same with the next. So we've got to build more faster. And now you've got to inventory. Well, we're not considering these things. There's the maintenance side of it. There's the, as I mentioned, the industrial engineering is another side. There's the process engineering. And so all of these things are known, and the construction clients will get there. But now that I'm looking at it as a more intentional assistance that we need to bring to them. So for example, I can make the most sophisticated piece of equipment and I can give you the keys to it, and it'll never perform the best day it will be was the last day that I'm in that plant, because my team has the know-how and the understanding to deal with all those problems. But when we don't have a client that's set up and ready to go to deal with that stuff, then we're basically not doing a service to them, and they're not hitting their ROI, and nobody's happy. So.
Well, right. And that's the buy-in, the cultural shift, and having the people with the knowledge to actually execute everything and take it to the next level.
And our experience with that is, again, when we say these things, it's like they make a lot of sense, but I'm not doing a good enough job of really fully explaining. And I take for granted that people know exactly what I'm talking about with it, because I can see it because of my 20 years of manufacturing experience. But so we've got to do a better job of showing that gap, right? So showing sort of like where you're at, what's good, what's your gap, and then how do we get you there, right?
Yeah, for sure. All right, everybody, if you're just tuning in, we got Brent McPhail on from Brave Control Solutions, and we're talking about automation in our industry, the lovely industry of offsite construction, modern methods of construction, whatever we want to call it. That's what we're discussing today. If you are out there, please make sure you go and follow us on our YouTube, subscribe, and ring that bell. I know it seems so minor, but it really makes a difference for everything that we do, and we love to keep growing the word. Why don't we take a few comments? Let's say hi to a couple people in the audience, Brent, real quick, and then we're going to move on to some more topics as well. All right. Hey, Mitch Lund's in the audience. Good morning, everyone. Exciting conversation. Mitch, I would have to agree with you. So I love it. I love it. And of course, we already know Joel's out there. He said he does say hello. And I think you got somebody from your team here, Cooper Lane, answering questions in the audience, which is great. So we do appreciate that. Joy Wu, thanks for putting this convo together, BCS. Helpful to hear your perspective coming from a deep manufacturing background. That's amazing. Great. Hey, Titus Dare, how are you? Good afternoon, Titus says. I love it. We got people from all over. Stephen Della Duca, this is a great conversation today, folks. Very timely and absolutely cutting edge. Welcome to the future. Hey, and if you know any of these people and you want to give them a shout out.
Steve's one of our automation partners, so we can't do what we do. One of the nice things about being based in Windsor, right across from Detroit, as I always tell, we do more automation within 150 miles of the Ambassador Bridge between Michigan and Windsor than anywhere else on earth. Like this is the automation hub of the world right here. And so Steve is one of our local partners in Windsor here.
Perfect. Thank you, Stephen, for joining us. We love it. Make sure you hit that like and share button. And if you're not following Brave Control Solutions, you're wrong. You better be following. You got to watch what they're doing. These are the people that are helping bring manufacturing to our industry. And I mean manufacturing in the real sense, where we're using automation, robots, and precision all the way across the board. All right. So Joel Hutchins, I'm going to put your question up, but man, you got to put a Q in front of the question. Make it easy for us to find the questions. Put a Q in front of the question. Joel is never short for words or questions. So let's see what he has to say. He says, but BIM doesn't achieve the level of detail required to run these manufacturing machinery. Secondly, how do you expect architects, designers to know anything about this process in DFMA? This goes back to the education I was asking you about, doesn't it?
Yeah. Well, it's the education piece, but so, the BIM model, Joe, to be honest, I'm not as familiar with that, but what I believe is any type of a system that you can use to provide information to sort of limit subcomponents or create rules is what is going to be sort of the ultimate future. So once we have a machine established, and once we know that, don't put these two structures within 6 inches or less, this is where I believe it's going to go. Now, in the short term, what happens with an architect is once a manufacturer has a machine, and that machine now has a digital factory. And so what you guys would call a digital factory is a digital twin. It's a truly digital representation of the actual manufacturing facility. What that then gives them the ability to do is create whatever the thing they're building into a Revit model, or actually into any type of a solid design model. We can then import that solid design into our digital version, and then we run our machine in a virtual world exactly the same way it would run in the real world. And so before we've actually designed and released what they're building and sent it to the floor where the robot either crashes or has an issue, we have a way to intercept that step, do a virtual run through of that machine, report back what the issues are with it. So, here's a red area, can't do this, can't do this. Send that information back to the architect. Now, at that point, the architect has to make a choice, and he may say, due to structural design rules, I can't change my design. So we have to sacrifice that for this particular small design, we're going to have some manual intervention. Or what we're finding is he looks at it and goes, well, if I upsize the strength of this, then I don't need to use parallel structure here. Or if I change the location of this, like he has options that he can say, okay, we'll try this one. And he went from 60% to 85% or 90% or 100% by making design choices. And so when that's one specialized guy, he's now on his path to being able to do this. A new design firm comes in, you've got to re-go through those steps. And as I said, this is our break fix. It's the terminology that we use, where you have to break it to then make that fix. It takes time. It's not the smoothest way to do it, but it's better than just throwing it out there and seeing what sticks.
Perfect. Joel, thank you for the question. As always, appreciate you tuning in and sharing your insight and your knowledge. Jerry Dunn. Hey, Jerry. Hey, Brent. Looking forward to chatting with you again tomorrow. Hey.
Hey, Jerry.
Good to see you, Jerry. And then we have another question here, and we'll go back up. Joel's making some more comments, but I want to be fair to everybody. How about manufacturing for design, MFD? Isn't it more flexible, sustainable term and approach to mass customization? And this is Payman Pushti. Pushti, yes. I think that's how you might say that.
Yep. Yeah. So we've worked with Payman as well. How you doing, Payman? So this is the challenge that maybe at the beginning I kind of brushed over, but manufacturing for design is a way of saying we're going to set some constraints in the design of the products we're building. And absolutely, if that's achievable, and if your client base will buy that, that makes the sophistication of the automation reduce. The challenge that I have, and this is an expression I use all the time, is I've never been successful telling my customers what to buy. So in an environment where we're in the construction world, where people thrive on uniqueness, originality, you may get some gains, say in a long-term care facility where you're going to make 5 of them for a client or 4 of them for a client. There's some similarities there. Or in, affordable housing, you might be able to do that. But when I look at the industry as a whole, I think that there's a reward for being more customized and more flexible in construction more than any other type of traditional manufacturing. Nobody goes and says that they want their iPhone to be 2 inches bigger than their neighbors. But if they had that option, they certainly would. And to be fully honest, I believe that what we're talking about, this Snowflake manufacturing and this paradigm shift, I believe is going to circle back to the automotive industry, where someone like Louis Vuitton or Nike is going to want to build a chariot to go on the carriage, which would be the underpinnings of, say, a Rivian, skateboard, an electric battery and motors and powertrain. Once we've eliminated the need for seat belts because we've got self-driving and safety and all that stuff, designers are going to want to build this, and they're going to be looking at some type of Snowflake manufacturing because the traditional methods won't work. But it's down the road.
I love it. I think we need to get some T-shirts that say Snowflake Manufacturing. And just to get people to ask what the heck that means. I think
that might catch on. I don't know if A or DFAMA. I don't know if that's going to catch on. That's a tongue twister, but I think Snowflake Manufacturing might catch on.
Oh, just because you said that, I'm going to put this up from Joel. He said, sorry, but DFMA is DFAMA. You cannot achieve DFMA without digital fabrication.
Yeah, the difference, Joel, is the automation side of it. So when I'm understanding, and it could be my, I'm in this for 3 years now. I'm not in this for 20 years in construction, like a lot of people that are on this podcast. But what I'm seeing is that without me talking about automated systems, DFMA existed. So now I'm coming in and saying, yes, but we want to take the design that you're making that you would do in a traditional build, and we want to apply that to a manufacturing process. That's why I say that there's an additional step. The DFMA that you're using to design so that you can manufacture in some way in an offsite or prefab environment hasn't considered automation. There's even a different layer when you now consider automation to do that same thing. So that's the only reason I put that differentiation in there.
Perfect.
Maybe I got to work on it.
I appreciate you always striking up the conversation. It's how we learn. It's how we grow, for sure. All right, so let's move on down. We got a lot of comments here. I just want to make sure I say hi. Wayne Aston's putting some stuff out there. He says the ability to run design through a digital factory for conflict identification and resolution is a huge advantage over just putting a factory with automation equipment together and hoping it produces as planned.
Yeah, hope is not a strategy. He's exactly right. And that's what we're seeing a lot of. I will say this about the construction industry. Very, compared to the automotive, I can say the word balls. There's a lot of balls. There's a lot of ego, but not in a bad way. The construction industry is not afraid of a lot of things. They go and they do it, but we've got to get them in a little bit more. There's a lot of tools and things we can do to help. And I think the next topic we're going to talk about is basically one of those tools that, I think we've done a good job of explaining the challenge. Now we got to start talking about what are we going to do about it.
Yeah, for sure. All right, I'm gonna have to fly through a couple of these, or we're not gonna get through our whole conversation there. I mean, already striking up a big conversation. Joy Wu, hey Joy, thanks for joining us today from LinkedIn. All right, this is a long. Whether a factory is completely manual or one end of fully automated for Snowflake manufacturing, or the other end, we face the constraints of trucking transport as one example of constraints that applies to modular construction factories, regardless of how automated the approach. And on one end, say factory clients can only choose from a library of modular designs that have already been optimized for manufacturing and transport. On the other end, we allow clients to submit their non-optimized, optimized plans. He ran out of room to write there. So yeah. I want to add to like what Joy said. So that's how, there's a lot of that currently how it's done. And I'm probably going to scratch Joel's back here. Back of his neck's going to stand up because I'm sure I'll get this wrong. But when we look at that and the way things are happening now with generative design technology that's coming out there and parametric design technology, plans can automatically be generated, thousands of them now, that would work in that manufacturer assembly. Is that correct?
Right. Well, and so when I think about parametric design, I look at it from a different standpoint. My CAD to Fab is a version of parametric design. The difference to what we're doing, the advanced level to it is that we've got to incorporate obstructions, fixtures, tooling, clamping, all the things required in the manufacturing environment. But essentially a parametric design is a way that you use the XYZ coordinate data, the structural data, the properties of the material to then help you generate what you're trying to do. And so the only difference that we're doing is we're saying, yes, but to hold that up, you need a jig, you need something to do. And so ours has to look at it a little bit deeper. The other thing I would say back to Joy's thing is, Brave, because of our history, I think our strength is that we don't look at how it's currently being done. We do, but we look at that only sort of for entertainment purposes. If we knew and the current ways were working for construction, then you guys would have automation like the automotive plants do. 75% of your process would be automated. And so I think it's a worthy discussion. But like some of the things that we run across as I get exposed to more problems, the best thing that a client can do is bring me in and show me. Let me see what they're doing so that we can look at something from, you know, a Goodyear tire plant or an aluminum casting foundry and go, yeah, we got to do this casting process. And someone like, casting? What are you talking about? No, don't think about the metal, but this is the process we're trying to control. And so, you know, and the other side is the last topic we'll talk about is this data side, which is everything is a gut decision right now in construction. And there are millions upon millions, billions of dollars being lost because of the gut decisions. It's this analogy I say about like we're running through a forest with our eyes shut. And so if you're the construction guy and you're running with your eyes shut, how fast are you really running through this forest? If you can open your eyes, you can run that much faster. Now, when you're the guy who's running with your eyes shut, you feel like you're going fast. But when I'm standing next to you, I'm like, he's not going very fast because he doesn't know he has his eyes shut. And so our last topic is along those lines.
Yeah, and I agree with that. All right, so we're gonna say hello to a few people. Carson Holmquist, same thing. You know, a lot of frequently seeing modular companies severely limit their transportation options because they never consider transport constraints in the design process. And there is some of that going on out there as they think about this. But not only their design process, but it's really, you know, there's no uniform transportation code through every state. They're all a little bit different on what you can do and what requirements you need and what permits you need too. It's a very complex issue.
You know, the thing I'll add to that too is I hear a lot of times it's this 3D volumetric versus 2D, shipping air versus not shipping air. And if we could change that narrative, let's talk about shipping hours. Let's talk about shipping man hours instead of shipping air, because that's another thing that when the data is there to back up what the hour savings are, that topic comes back to, do we do a centralized factory somewhere and truck things? And this isn't exactly I know that Carson had a different point where he was saying about like the design for shipping. Don't put if you've got 11-foot width, don't make a 12-foot unit. But there's a much more to that. Centralized versus decentralized, mobile factories versus not. So it's a huge topic for sure. And there's an understanding problem and a data problem. It's again, we're making gut decisions.
That's right. And all that information could be compiled into a system that does that. So 100%. All right. Hey, Peter Molinar. What's happening, Peter? Snowflake Manufacturing, a crystalline method. Love it. Peter. Good to see you, my friend. Oh, look at this guy. We got Doug Pill. Hey, Doug. I hope you're well. Doug Pill's from Prefab Logic out there in Boise, Idaho. In fact, we did our live show with Doug Pill out there not too long ago. So Doug, always good to see you. And Doug sits right there next to AutoVol, which is a highly automated manufacturing facility.
Yes, yeah.
So getting the attention of some of the players in the industry, which is always nice to see. All right, we got Nirav Panchal. I hope I said that right. Thanks for conducting this meeting. Thank you very much. We are the future of smart building, Mon Ung says. So I appreciate that very much as well. Let's hop into the conversation now and get a little bit back deeper into what we got. Can you believe it's been 47 minutes already?
Yeah, it's crazy.
That's how fast it goes by, right? I know. Mm-hmm. Well, we have fun with it, right? That's what it's all about.
Yeah.
All right, here we go. Automation, readiness, and IC maturity assessment, gap to good. IC is in industrialized construction. Walk us through.
So we've talked about the Snowflake manufacturing, which I think is the fundamental challenge. There's traditional manufacturing methodology that can help construction clients, no doubt. But I think at large, the bigger challenge in the industry is the Snowflake. Then we talk about the DFMA and also for the automation side. We talked about the manufacturing organizational structure, which is helping to get that readiness. What we realized probably a little later in the game than I would have hoped is that when we say these gut decisions, what we need to do is we need to basically work with the client to assess where they are from a best practices scale. And it starts with culture. It starts with their readiness. It starts with their desire to grow, their desire to change, gets into automation, data, technology. And so what we're trying to do is we've put together with a company, Haley and Aldridge, that we do our consulting with. They're good friends of ours. They're lean consultants. We've put together this automation/lean IC maturity assessment, and it's our gap to good. And so what we're finding with that is that A, it gives our clients a benchmark of where they are. B, it outlines clearly so everybody's on the same page of what the future state looks like. And C, it gives us now tangible, actionable things that we can do in this industry. And I think why it's so powerful to get them to good, and why it's so powerful is that I hear so many people say, you know, I look over at a floor plan and I want that automation. But there's no check that you can write that just gets you that. You've got to adopt it, you've got to evolve it, and you've got to build it yourself. And in order to build it yourself, you've got to see where you're at. And so then what this does, we do it in 3 levels, right? So basically we take the offsite or the onsite right out. So the first level is, you know, you're building offsite, but you're doing it the same as onsite, just in a climate controlled area. Then we go to the next level, which is a very lean operation with some small like automation. And then we go to the third level, which is fully automated automotive type manufacturing. And so that's where we're trying to get to. You know, as we do this assessment across multiple companies, we're finding that, you know, everybody that's trying to do this is at a level 1, if not maybe bridging into a level 2.
And you're finding companies that are doing this. You guys are busy, huh?
We're busy, yeah. So believe it or not, I'm not a consultant by my nature. My goal in this world is to build machines. I love people to give me a challenge, and then I go and I build them a machine. But the problem is, if I build you a machine and I give it to you and you're not ready for it, you get really mad at me. And so what I've realized now is that reluctantly, I've got to partner with folks like, you know, Nick and Melissa at Haley and Aldridge, so that we can make sure that when we give you the machine, you can get the ROI that you banked on, that you calculated. And so with that knowledge, we're having a lot of success, you know, performing these things.
Perfect. All right, last topic, and then we're going to hit some questions to wrap up our hour here. So data-driven manufacturing execution systems. Walk us through what we're going to talk about here, because we all know data is the leader for everything in this world anymore. And once you understand how to use that data, then you can fine-tune your systems. But I have a feeling you're going to get a little deeper than that.
So back in 1996, just before I started my career, the company that I had worked for at the time, an engineering company, was one of the pioneers in manufacturing execution systems for automotive. So this came in, it's bottleneck traction, it's blocked, it's starved, it's how to build buffers, it's cycle time. And so what they came up with was this, they didn't come up with it, they applied this lean tool, OEE, overall equipment efficiency. It's a measure of performance, availability, and quality. And so you start with 100%, and then these things detract down. And so the theoretical number in traditional manufacturing is 85%. When I walk around, and I mean every construction job site, every offsite factory, I haven't toured Autovol or some of the more advanced factories, but what I see is that people aren't standing at the machine pounding the nail they should be pounding for anywhere near 85%. And this is where your losses come. And so as a client, you're trying to determine, do I hire supporting staff, which is overhead, to keep the line flowing? Then you're struggling with this multi-constraint decision-making. You know, you've got blocked and starved conditions, upline and downline. And so what we do in the automotive industry is we create these benchmarks, we automatically track them, and then we set targets that your production staff, when you have your manufacturing organizational structure, can work towards. And so what I'm saying at this point is automotive doesn't even track things outside of the machine, but they're very fortunate because, you know, 90% of a line on an assembly plant is in a machine, and it becomes very easy to extract that data. When I talk about in construction that we're making these gut calls and these gut decisions, it's because we don't have the data. We don't know whether we should prefab X or prefab Y. So all we're able to grab is the really low hanging fruit because we're sure of it. And so what we're working on is working with clients to basically set the pilot, track this data. And what Brave is in the middle of developing right now is a method that we can actually use to capture the data automatically. It's this expression I always use, you got to get that data for free. And if you can get the data for free, then we can report on it. And it's going to open up, I believe, the ability for us to work with general contractors, people doing the self-perform work that are struggling to make these decisions right now, but are doing prefab. I think we can move the bottom line because of the waste in their companies by 10, 20, 30% in profit. It's hard for me to even conceive how inefficient I see this out there.
So walk me through. So like, here I'm a company, I'm listening to this, and this all sounds great, Brent. How do I get the data? Do I have data? I know I have data. How do I capture the data? Because I'm not currently capturing the data.
That's
and
right.
If I do have data, it's probably on about 1,000 different spreadsheets,
yeah,
across
and
40
it's
years.
not even that. It starts from the theoretical understanding of what should be happening. So let's say I go to a plumbing contractor who's doing prefab work for plumbing. And today they're building copper fixtures that are going to go into a wet wall for a hospital somewhere. And so I look and I see they have 6, jigs set up. And as I'm touring their facility, I don't see anybody standing at those jigs. And so then my question is, where are they? What are they doing? And what we don't know is, are they prepping something somewhere else? Are they kitting something? Are they looking for something? And so when I start to look and I say, okay, what did you guys set was the target that this person was supposed to be making those fixtures for? And they don't have the answer to this. And so this is the type of thing that someone like us that has this manufacturing automotive background, but also has a construction domain experience, can come in and say, okay, guys, your guy's working 15% of the time, but he's working and doing stuff 100% of the time. If we can get that production time from 15 to 40 or 50%, what does that do to your labor component? We can't find workers. And I believe they're being, between workers and scrap, there are so many inefficiencies right now. Every 4 buildings in construction, they throw one away. That's a 30% scrap rate. When you put it in perspective like that, it's monstrous. Well, I believe when you look at a labor component that's working at 15 or 20%, and you can move that to 40 or 50%, you've got, 30 or 40% more capacity with the same amount of labor force you currently have, if we start thinking about it in a manufacturing way. And that's where, this MES system that we're trying to develop right now is going to bring those answers to the end customers. Going to give them the data that they need.
So say that again. 1 out of every 4 buildings or 5 buildings is
thrown away.
So
what we're understanding in our early stages is, when you've got a 30% scrap of material rate, when you look at it from the way we look at it is, imagine if every 4 cars that Ford built, they put 1 in the garbage. Like, it's not sustainable. And the first step to that is understanding where that waste is, understanding where that waste is coming from. And so again, if you go back now to what I said about the manufacturing organizational structure, in the automotive industry, Ford probably has 1,000 engineers dedicated to just that, to waste reduction, to their industrial engineering and their process engineering. And so we need to bring this understanding so then we can bring tools. And I will say one other quick point. I hesitate to talk about tools because there are systems out there right now that do the product management tracking, and I won't name them, but they're fine tools. But I hate to say it like this, it's garbage in, garbage out. If you don't have a way to get the right data, there's a lot of tools that can organize it, can present it, can send it in the cloud, can display it on your phone. But if you can't get that data, and so Brave as a company in automotive, will do a pilot for what's an IoT pilot, so industrial Internet of Things. With Ford, one example we have is like 50, 60-year-old presses. They're running old hydraulic units with no computer controls on them. Well, we'll come in and we'll retrofit external computer controls and sensors to measure vibration, to measure sound, to measure temperature, so that instead of us doing preventative maintenance, which means you go and change the bearings on a pre-scheduled amount, we're now predicting when the bearing is going to fail, so that you can then take that data and make that weekend the weekend you change it. Well, that's that level of data versus physical touch that our company specializes in, that can then present the data to these software companies that are able to then provide the reports and whatever. And so that's when I say we're developing a solution, we're by no means developing the data software side. We're developing the how do you get the tangible data from the floor into the database that then can be reported on many different ways.
Sure. I mean, listen, everybody out there, if you're in the manufacturing world or the sales world, CRM, any of those things, data in, garbage in, garbage out.
Right.
Like the numbers are what the numbers are, and the information is what it is. And I think the key takeaway, Brent, and how you guys are approaching this is you're a partner to these manufacturing facilities or these developers looking to change and automate better. And you're absolutely right. We cannot continue to throw 30% of our buildings in the trash. Go by any job site if you disagree or don't understand this, or maybe you're not in construction. There's dumpsters out there, and those dumpsters are full of 30% of that product that they're building those homes with. So that doesn't need to be that way. No other manufacturing industry would ever even conceive doing.
No,
it's inconceivable, as they would say.
Right.
Right.
But to us, it's opportunity everywhere. Like if it was 1% scrap, we'd be looking at something else. We'd find, it's opportunity. It's just tremendous opportunity.
It is. All right. So let's just do one or two more comments, and then we're going to wrap it up here. We're about to the hours. Andrew Stern says, I'm a big fan of Elon's approach to SpaceX Tesla's manufacturing systems. Love this conversation. Applies well beyond manufacturing systems. Make your requirements less dumb. Try to delete part of our process. Imply, optimize, accelerate, cycle time, and automate. Yes, I agree. And Elon, if you're out there listening to me, I do have one beef with you. Please don't send your lawyers at me. But in my world, you have 4 windmills on all your cars. Why are you not generating power and bringing it back to our houses? Why do our houses have to charge your cars? And that's kind of what's happening. And I argue this all the time, and I'm bound to get a phone call at one point. Hopefully it's from him and not his lawyers. Who knows? Tell me to pipe it down a little bit. But Andrew, thank you for that. You want to make a comment on that before I move on?
Well, I was just laughing. He would talk about thermodynamics and losses and all these reasons. So he's too busy just charging his batteries back up every time he uses those windmills to come to a stop sign. But anyway, the point's still interesting.
It is. Well, you got to have a little bit of fun and a little bit of hope. There are definitely people out there that are a lot smarter than I am. So my job is to just help raise the questions, good, bad, or indifferent. And that's what this show is all about. Brent, thank you so much for tuning in today. I really appreciate having you on the show. We're going to wrap it up with your one thing. If you were to leave us with one thing that all manufacturers, developers should be thinking about from this conversation, if you wanted to leave them that one thing, what would that be?
The one thing I would say is that this is a paradigm shift, and we are at the unprecedented stage of being on the early adopters of this. So anybody who's listening to your podcast right now, anybody who's listening to what I'm talking about the automotive side, don't be the guy who had an opportunity to invest in Apple or in IBM back in 1980 and didn't do it because of some reason. The opportunity we have is unprecedented, and it's right now. Go in, jump in the pool, both feet, let's go. That's the one thing.
Yeah. Hey, listen, and I'm going to put up one more question. I think this is super important because if we didn't cover it, we should. Safari Broadcasting, what services do you provide? Let's put it up there for you.
Sure. So we're a turnkey machine builder. So if what we'll do is we start the process by coming in, observing your challenges. Then we will help you build a business case and an ROI to solve that problem. Then we will build the piece of automated equipment that will solve the problem. So from consulting to problem identification to turnkey automation. That's the one line. The other line is this data that I'm speaking about, the manufacturing execution systems. Right now we're at a pilot stage for that, but there's gains and opportunities right there for us to enhance your data tracking ability to give you the information to make decisions. And then the third business line that we have is what we call factory in a box. It's what we're doing with Haley and Aldridge. And so it's how a client will come to us and say, look, we want to build this product. We don't know what the cost per foot's going to be. We don't know how much square feet we need. Can you help us establish our manufacturing process from the ground up? So those are the 3 lines of business that Brave works in.
Awesome. Hey, listen, Safari Broadcasting, thank you so much for tuning in. Jeff, Rob Billard says, think Brave. I love it. I love it. All right, listen, everybody, that's a wrap for us today. If you are not following Brave Control Solutions, you're wrong. Make sure you go out there and follow them right now, but not before you go to Dave Cooper Live YouTube channel and subscribe, please. All the support is amazing. We appreciate every one of you and all of you that tuned in today. If I didn't get to your comments or questions, we will get to them after the show. But for everybody else out there, we hope you have a wonderful afternoon. Brent, to you and Brave Solutions team out there, we really appreciate having you on the show today. And we are moving this industry forward, and we're going to get there, I promise. And I think you feel that as well.
Yeah, thanks, Dave. I really appreciate the time. And I do have to give you kudos. You having a voice and having the audience that you have, giving myself an opportunity to sort of share what I want to share. And, it's about getting the message out. And I think that this is a really valuable service that you're providing. So all of the stuff that Dave said to subscribe to, I fully endorse.
I love it. All right, everybody, listen, thank you so much. I'll give you a crowd cheer before. I love it, Brent. I got some new toys. I haven't figured them all yet, but we're getting there. All right, everybody. Thanks so much. That's a wrap. We will see you on Friday with Mark Bare Naked Willie, BS Friday, Building Science. If you want to learn how to build better, live better, and control environmental waste like the 30% that Brent was talking about, that's another great show that you need to tune in for this Friday, 1 p.m. Eastern, 10 a.m. Pacific. Brent, don't go anywhere. I'll come back to you after the show. Everybody else, have a wonderful day. Thanks. Bye now.